Hi, I'm Andrés.
I'm Omar.
And for the past roughly 3 years, we've been working on, all right, keyboard. On Folk Computer, which is a tangible operating system. We'll explain what all those words mean. And today we're going to talk about Folk. We're going to give you a brief overview of Folk in general, and then we're going to talk specifically about this thing that we call the Gadget.
This is the Gadget. Well, this is one of them. There's also one over there.
So for Folk in general, okay, wait. Okay, great. For Folk in general, the video that I had just played behind me is an example of a Folk program. So Folk is a tangible operating system, which means that we have physical things in the world that move or that get shown to the computer, put on the table, and they trigger digital actions. So little computer programs, lines of code, projecting these little circles, playing these music notes. And so a prototypical Folk program looks like this. There's a little bit of text. It says, wish this is outlined gold.
And so that's the source code of the program in this case. And there are a bunch of other programs on the previous slide.
And then this specific one I printed out today. And so it has its little date. But these black and white squares are formed to create what's called an April tag. It's basically like a minified QR code. So whereas a QR code can hold lots and lots of data, by lots I mean like a URL, this can hold very little data, by which I mean like on the order of bits. So all of our April tags together are patterns of black and white squares, and they represent the numbers, in any given Folk machine, they represent the numbers 0 through 40,000. So this particular one that I printed out for you all today is 1364. So in the last 3 years, we've apparently printed out 1,300 programs, which is fun. So these two come together, and this is what, you can notice that there's a $ in front of this. So in our programming language, which is also called Folk, this $ is a variable, and we inherit that from this language called Tickle. But ours is special because it's not just a set of abstract pieces of data. When you show it to the computer, by which I mean you put it on the table, there's a projector and a camera that are running, connected to a computer that's running the Folk OS. And Folk's whole job is to coordinate all of this to fulfill this wish. And so we wrote, wish this is outlined gold. And so this white piece of paper is pretty accurately outlined in the color gold.
And so ordinarily, if you had a Folk system, like the one here, which we'll talk about briefly, or the one we have at our studio, you would sort of have like a desk like this with a rig mounted above it with like a camera and a projector and a computer system in that rig. And then you would kind of put one of these pieces of paper down, and the rig would see the tag, and then it would execute the code on it, and maybe get some effect, either a projection or something else. And these are programs, they can do whatever you want, right? Like whatever you code up a program to do in Folk, you can do.
So two things. Folk is open source. It's on GitHub, folkcomputer/folk. Feel free to check it out. Try running it on your laptop, and if you have a projector lying around, try running it, and a Linux machine, try running it.
Yeah, it's a little bit involved still. It's gotten easier over time. There's a checklist of parts you could choose to maybe buy, but part of the reason we're talking about the Gadget is that there is still a process to setting up like a full-fledged Folk system.
Yeah, so we've managed to get 35 strangers to set this up.
At least 35. I mean, there might be more. Like people often set it up and they don't tell you, and then like 6 months later they email you and they're like, it doesn't work. And then we're like, why didn't you email us?
Right, you don't know about it until something goes wrong. So it's an open source, tangible operating system. So a lot of these GIFs actually come from our open source contributors. We can do things like explore math. Oh, the videos aren't looping, whatever. We can put objects into buckets. We can recognize bespoke objects, not just the April tags. We can move programs in the real world, and then digital stuff happens, right? Like that's the whole loop. And in fact, if you are in batch or are an RC alum, through that little window over there in that room is this. This is the other side of that window. That's Omar and Jessie. Jessie, like 99% of this credit goes to Jessie. Jessie donated a ThinkPad and set up a projector, and I think,
We
there was a
just came
camera.
by it when it was like completely done.
Yeah,
And we're like,
yeah.
this is great.
Yeah, and we were like, good job, Jessie. Jessie's also very into, oh my God, what is it called?
Super Collider?
Yeah, Super
Yeah.
Collider. And so this happened.
Okay, and then we can go and
Oh, so it's selecting. Yeah.
Using the actual spatial component.
I really wish I
well.
hadn't said that. It's just evident from the video.
Just tuning up the tempo, is that the situation?
Yeah, and then there's this other one, which is also now, I can reveal to you, also is in that room. So each one of these, so this one, okay, to explain for a second. This one, I'm not going to play it again, opens an image of a waveform and then plays the associated song, and then you can use the two little cutouts of the hands to as interactive, tangible playheads, right? So you can where do I want this clip to start? You don't have to drag a little representation of a window or use your little cursor.
Also, you could have one person's manipulating the track and one person's manipulating the selector hands or whatever. You can kind of have these multiplayer interactions.
Yeah, you get these very old school workflows of it's literally feels like tape, but also you get all the affordances of MP4s or no, whatever, MP3s. Additionally, you can make it do things because it's Folk is a custom programming language. We spent an afternoon writing a thing that would support this. So like the program you saw earlier was wish this is outline gold. These say wish this plays note A, B, C, etc. And so this is mimicking a regular piano, but because it's connected to Super Collider, you could imagine doing literally anything, right? And it doesn't have to stay in the form factor of a piano, right? This looks very, this looks like a musical instrument to us, but you could imagine, I don't know, turning an orange into, tracking an orange and turning that into music somehow. I don't know what the details
I was
are.
just saying earlier, you could also plug in a MIDI controller and write a folk program that reads from it, and you have the whole sort of world of computing available to you.
So if you were to visit us at our studio in East Williamsburg, you would see that we have a completely self-contained editor, which is very important. This sort of takes it from a hobbyist thing that we call an operating system to an actual operating system with its own bespoke editor, with its own bespoke language, with its own actual interactive loop.
Right, you don't need to pull out your laptop to create a program, which is not true of it's surprising how few platforms that's true for.
Yeah. So here I'm writing wish this is outlined green, and then I press Control S, and then it saves itself and makes it green.
So this is the program.
Yeah, so keyboard program that represents our virtual editor, and then a display above. And then if you were to press Control P, you would see something like this. We have a little printer in the corner, and Control P actually prints, right? It dedicates a little number, it saves a PDF, it prints it out physically, and now you can put it on the table, and it binds and just executes. So you could wish something is displayed your name, you could take a slice of the camera, you could do
You could
any-
exec curl, you could make it an HTTP endpoint, you can write some C code, you can write a shader.
We explicitly encourage doing very unsafe things, basically because it's not, by default, it's not connected to the internet. So if you break it, you're just breaking your own computer. But I think it really is important that it's not a toy sandbox language. You can legitimately do anything, right? The answer, this is an annoying answer, but the answer to can it do X, Y, Z is yes, if you know how to program that thing.
Yeah.
And so this is our studio at Hex House in East Williamsburg, and our little studio's up there. And we have a camera, a computer, and a projector all mounted to the rigging above our desk, and it can see roughly this. It can see roughly this portion of the table, and so when you press Control P, you get a little physical program out, and you get this is like the loop, right? You have all this hardware that's set up, and so if you come visit us, you can like try out Folk yourself.
It's funny, when people set it up, they always remember the projector and the camera and the computer. Everybody always forgets the printer. The printer is actually very important.
Yeah, it's a tangible operating system. Okay, but we are here to talk about the Gadget. So I've oriented you towards what Folk is in general, but through magic, we're going to show you the Gadget here that Omar is holding.
Yeah. So this is a Folk Gadget in my hand here. You can see it has a projector sticking out of it, and a computer, and a trigger button, and a camera. So everything that was in that ceiling rig is in here, and we'll talk about that in a little bit. But we have a couple programs here, so I'm just going to try to run them, lighting, willing. There's another Gadget over there, by the way. That one's smaller, and it needs to be plugged in. This one doesn't need to be plugged in, which is nice. Yeah, so I'm running this camera slice here. Andres, do you want to put your hand here and see that? So this just displays what the camera is seeing. So if he puts his fingers there, if they put their fingers there, you can kind of see the feedback. We only have a couple programs here, but this kind of shows the basic idea, especially if you've seen the Folk system over there before, or if you've seen this stuff online. And I can, this one outlines it in green. I probably have another program. I can probably like go over here too. Maybe not. I think I have another program under here. Yeah, what's up?
I mean, just importantly.
There we go. Yeah.
You can also move the program.
Yeah. And you can have as many running as you want. So yeah, that's the basic demo of the Gadget. So I think we wanted to talk a little bit about the story of how this got started, and then some of the sort of design problems, technical problems, and then exciting applications that we've either have already done or are excited about doing in the future. I think this started when you sent, like 3 years ago, when you sent me a link to this Nebra AnyBeam projector, which is like a really small laser projector. Do you remember where you found it?
I mean, because this is my full-time job, I just often Google for new projectors.
Yeah, so this is a pretty unique one. It is a laser beam scanning projector. So this was available, I think we bought one in like 2022 when we were getting started. And it was available then, it quickly became unavailable. It's a laser beam scanning projector. So it's focused at any distance. Like you can see that this thing doesn't like blur out. I can just like move it close, I can move it far. It's still sharp, the text is still readable. I don't need to like turn some focus knob. It doesn't make any noise. It doesn't make any noise. There's no fans. The power usage is really low. It's really small. Like this thing is kind of big, but the projector inside it is actually pretty small. Most of the volume is actually the batteries. That one's even smaller. Yeah, power use is pretty low, so you don't need like a separate power source. You can just power it right off the USB port. And the images are kind of cool. Like I don't know, it just looks different from a normal projector. It's kind of worse in some ways, better in some ways, but it's different. So long story short, we couldn't buy these kinds of projectors for long. They quickly went out of stock. I was like reading up on the history of like all this kind of projector. There was another company that made them. They also kind of went out of business or stopped selling them. There's like a subreddit with a ton of people who were following that company that was making these mini projectors. And it turns out, and like I would find all these posts on the subreddit for this company Microvision, and then I would dig into it and I would find they were all just like speculating on the stock. Because there was just like, everybody thought that there would be like a projector in the iPhone or something, or that they would be useful for LiDAR on self-driving cars, and so people got super excited, and that's why there's 40,000 people in the subreddit. Anyway, they don't sell anything anymore. So we had this one projector, and then we kind of made all these weird prototypes with it. This one is just like, it looks like my hand, so it's like me holding a projector and a USB battery and like a Raspberry Pi Zero, and just like pointing it at the wall. So that was the first iteration of the Gadget. The second iteration, we zip tied them together, so it's a big improvement. The third iteration, I found this like toy in my parents' basement, this like yellow trigger thing, and then zip tied that to everything. And I also broke my phone, so I attached my broken phone. That's the red thing there. And so now we have this sort of complete, it has a camera now because it has a phone in it. Yeah, and then now with this, we could actually start to kind of play around with it and show it off to people, and we could do some stuff.
Yeah, so if you click one more time.
Natalie's body right now.
Basically, we just spent a while inviting friends to do random things with it, like pulling up random YouTube videos, or the one in the bottom right that's still playing is like the selfie camera's just open, so she's just projecting her face onto her friend's face. These are just random Hex House people. And up top, the video on the left is our friend Michael Achillian. That's Kit Volta in the middle. And then this is our friend Coven or Kawandeep. A lot of you know these people secondarily or tertiarily. And yeah, people like would variously pull up their selfies, pull up, like take random photos, airdrop photos to Omar's random, like un-Apple logged in.
Yeah, I mean the screen was literally cracked, so you
yeah.
could barely interact with the phone.
Yeah,
that's why I wasn't using it.
Yeah, you could like send YouTube links and then like hope and pray and click and open stuff. You could open up like bespoke AR web projects.
I mean, a lot of people like playing with the camera feedback. You just open the camera app, and then you just, it can see what's projected, and it's projecting the camera. So you get these kind of interesting feedback effects where you'd see it converge on a certain color or whatever.
Yeah, we spent a while. So, okay, again, this is all not folk. This is just innovation through random things Omar found.
There's also no programming involved. It's literally, and no 3D printing. It's just zip ties.
But importantly, like the form factor, like even though it was still running iOS, it didn't feel like iOS. It felt like, I don't know, adding a little computer to the world. It felt very magical.
Right, and
so,
it's like instead of you being inward, you're like showing it off to other people and like seeing how it interacts with various textures and people in the environment. Like there's a sort of just very different set of interesting things about it, I think, and that's why people were excited about playing with it.
The like mechanical, boring, technical explanation is that you're like screen sharing to a projector. The like physiological, phenomenological thing is that you're like shooting a video onto random stuff,
Right,
which is cool.
there's not really any other way to do. I mean, even in a standard folk system, you're kind of confined to this plane, at least traditionally.
Yeah.
So there was still this problem that like we only had one of these projectors that we had randomly bought in 2022. Thankfully, last year I got a message from a friend of mine, completely randomly, that was like, "Oh, I might have a way to source new projector modules," because his friend's dad, used to work for the one Taiwanese startup that makes these projectors. So this is the startup in Taipei. I was talking to them actually. I was talking to a guy over there, and he said they started by making the microchip, the MEMS chip that steers the lasers back and forth, and then they kind of moved upmarket to making projectors because it's like, I don't know, like that's how you start a company in Taiwan apparently, is you start by making the hardware, and then you're like, okay, maybe we should make a product. So we did a group order. We bought we got a bunch of friends together and bought like 15 of these. This is one of them. So it's actually very similar to the projector that we had before. It's just as like in development board form. So it's really small. You can see it's like roughly phone-sized. HDMI port, USB-C for power. In the back, there's also one that's USB-C only, and it just projects a little image there. A lot of the photos you'll see will have these scanning artifacts where like you can see part of the image is cut out. That's just a problem with if you take a photo of them in real life. They don't look like that. You can see that one doesn't look like that. This one also doesn't look like that. But it does actually cause some technical problems, which I'll talk about later. So at this point, we have a few of these, and so you start to see some weirder pre-Gadget prototypes. So this is the 3D printed Raspberry Pi case zip tie to a projector era of Gadget design. So still a little bit of 3D printing, but not a lot of custom design. This kind of worked. I mean, the problem, and I would like just drill holes into the cases to like screw the camera in and like, and then zip tie the thing on top. The problem with this era was there are cable strain problems, which I'll talk about later, and also it was hard to keep them calibrated because everything just kind of wiggles a little. Like it's not like everything is solidly attached, which means it's really hard to get even this level, the level of accuracy that you've seen earlier today with the gadgets. And we're also going to talk about that a little bit more. So finally, I was like, okay, I guess we have to like learn how to CAD things and 3D print things. So I started trying the software Shaper 3D, which is really fun and which I recommend. It is mostly made for the iPad, which is kind of cool because I've never in my life had another use for my iPad. This is the only thing I use my iPad for. It's like a really cool, I have this like arena channel, like two-handed UI. Like with your left hand, you're like manipulating the camera, and then with your right hand, you're like drawing stuff, modeling with a pen. And so you feel like you're actually like locked in. And it's like a totally like nonverbal activity. You're just like solving these weird puzzles in the coffee shop on your iPad. It's really fun. I would recommend it. Shaper 3D. Also, this is like a fun, like it's fun to learn CAD this way because you don't have to be that creative. Like we kind of knew what we wanted. We kind of knew what the hardware was going to be. Like we knew that, okay, there's this projector that's this shape. There's this computer, like Raspberry Pi or later Orange Pi, that's this shape. There's this camera. There's like a battery unit. And you can basically like either just like sketchily model these, or you can often download the models for these off the internet and just like import them into the CAD software. And then you just like, okay, I have all the things inside. I'm going to like draw a box around them and then just like take the holes that I want to screw into and like project them outward into the box and then screw everything in. And then, you know, you're like, okay, it looks bad, so I'll round the corners. But you can kind of like iteratively get to something that looks reasonably nice and like that fits everything well. And there's also kind of a difference between CAD and doing like video game 3D modeling, right? It's like CAD is designed so that you can do all these kinds of projections where the screw holes end up in exactly the right place to fit your hardware in. And you know, you can measure everything really accurately. I got really excited about calipers, which I'll talk about. So we had this folk system at Hex House. Everything's in the ceiling. There's a system there. Everything's in the ceiling. All the stuff in the ceiling basically just has equivalents, you know, in this box. And that's, you know, what the Gadget is. We actually, you may have noticed, we actually have two gadgets here. I think we didn't need to bring two gadgets, but I think it's fun to talk about the contrast between them because they do represent kind of different eras of gadget development. The one on the left, the one that's mounted there, is a sort of Gen 1 gadget. It doesn't have a battery, so you can see it has a single USB-C power brick. It uses a Raspberry Pi 5. It uses the dev boards that we imported from Taiwan, which have an HDMI input, which means you can plug a Raspberry Pi 5 into them because the Raspberry Pi 5 only outputs HDMI. It needs wall power. It's kind of smaller than the big one. The new one has a battery, which is kind of great because you can like walk around a room, you can point it at things, you can take it to the cafe without them yelling at you for bringing like a 20-foot extension cord. It's kind of heavy. It has a trigger button, which is also nice. I'll talk about that a little bit when we talk about the QR stuff, so I can, you know, I can trigger. Yeah, I can trigger. Unfortunately, this new one, I mean, the reason we started this new one is finally these projectors can just be bought on Amazon. It's called, so you can buy a projector called the NeBeam on Amazon, which is basically the same thing. But it only has a USB-C video input, which means you can't use it with a Raspberry Pi 5 because the Raspberry Pi 5 doesn't have USB-C video output. So we need to switch to the Orange Pi 5, which is very similar, but has worse software support and is worse in various ways. So this one has an Orange Pi 5 in it. And I'll also talk about the technical issues with that. But the nice thing about using the off-the-shelf projector is we can actually, you know, make more than a few of them without having to like call up the Japanese electronics store to import projector dev boards. So I guess we want to talk about a few different classes of problems that we've encountered with the Gadget so far. Not all these are necessarily fully solved, but we've made decent progress on all of them. First is just like doing the physical design and assembly. I think the first big issue was just like putting too much strain on the cables. Like I would just not think about the cables and just like stretch them. And then you'd get these weird like the HDMI cables like pushing against the port and the image only works half the time, or it's like red tinted or whatever. I designed a lot of gadgets that were not physically assemblable. Like you just couldn't put the things in the right order, or like my hand wouldn't fit inside, and so I literally just like couldn't screw everything in. So our friend Colleen, who makes this thing Poetry Camera, was telling me once that, you know, you have to think about when you're making these things, you're not just making the actual device, you also have to think about you're making the process by which you're going to make the device. And so you really have to think about that manufacturing process as you're doing the design. A couple cool things that we use a lot that I didn't know about: heat set threaded inserts. So these are brass thingies with threads inside that you can screw a bolt into, and then you just put a soldering iron on it and it just sinks into the plastic, and now you have a threaded hole that you can screw stuff into. Really nice if you like we use it for the handle, so you can just take the handle right off and like put it on a tripod or something, or put it on an arm. We use it for the front and back panels, so you can take the front and back panels off if you want to plug an Ethernet, like anything where you're like, okay, I might actually want to take this off in the future, if I'm doing maintenance or I want to switch it to a different form factor or whatever. So these are really cool. Calipers, again, really cool. I got sick of like squinting at my ruler, and yeah, often you are making holes that are like millimeters wide because you want to put a screw in there or something, or like you want to connect it to a screw hole or a threaded hole like on something you're putting inside. So caliper is very, very useful. And often like you want like a little bit of clearance for the screw, like you're like kind of thinking in terms of fractions of a millimeter. So these are, I think this photo is from like October. So these are various iterations of the Gadget over time. So I think the top one is the oldest, and then they get newer and newer and newer, and then they get newer and newer, and then this one is probably like six more later. They get bigger over time too, because they grew batteries and stuff like that. The first ones took like 7 hours to print. The current one, this one takes like 20 hours to print. Fun fact, actually, the 3D printer that all these are printed on, I bought, is an Ender 3 that I bought on the Recurse Center mailing list. I don't remember from who, for like $40. But yeah, so the feedback cycle is kind of longer than you would like. But I feel like the psychology is often that you're like, I don't really want to, like, I kind of just want to print it and like see what breaks and then try it again. Like there's something about that that's more attractive than trying to figure everything out in your head. Like just because you get to work with physical objects, you get to measure things, you get to sort of see what the overhang is physically. Yeah, so assembly, I think we've gotten pretty far on. There'll probably be a few more revisions, but this one has been pretty stable. It changes a lot less now than it used to. Next big point, powering. So my friend Kevin, who helped with ordering all the projectors, has this whole theory. He also does a lot of hobbyist hardware stuff. And he has this whole theory that the hard part is actually not computing anything. It's actually just keeping the thing powered. And there's some truth to that. So the old versions are all wall powered. New version has a battery. Wall power is actually, even wall power is pretty annoying because it's like these things require a special power brick. You can't just use your laptop charger, which means you have to have a box with the power brick in it. So eventually we found a battery system that we didn't have to design ourselves and just got off the shelf. I think probably ultimately we need to like make like a carrier board, like just design a whole board that does all this stuff, but I didn't really want to get to that before we even had any interesting applications. But this has worked pretty well. I mean, you can see it's still running, having not been plugged in. So we're probably going to stick with this for now. The batteries are pretty big. These are like 18650 batteries, which is like a pretty standard kind of battery, also thankfully, but it does take a lot of volume and weight. Next big issue is connecting to the Gadget. So I remember meeting somebody who is like an art and tech person and does a lot of interactive physical installations, and they were like, the first rule of doing any interactive installation is you never rely on Wi-Fi. Never rely on Wi-Fi. And unfortunately, we do rely on Wi-Fi. I mean, it's kind of hard to, like this thing's not going to be plugged into Ethernet. Like we're walking around the room, we're like pointing at things. I think it might be good to do Bluetooth low energy or something, but anyway. You can't really debug it without having a connection to it. You can't really like tell it to calibrate. You can't like troubleshoot when things go wrong. You can't update it. So you kind of need it to be connected to a laptop, at least for now. We might, noodle with that a little bit. And so like basically the big question is like, okay, you take the Gadget to a new place, like a new coffee shop, your friend's house, whatever. How do you get it on the Wi-Fi? Like, do you type it in ahead of time? Does it have an ad hoc network that you connect to on your laptop? Maybe you scan the QR code? That's like a pretty good option. We've like tried various of these. We've had like Wi-Fi driver bugs that mean that like the ad hoc network thing doesn't work. Yeah, lots of different stuff. But for now, mostly, we often take it to places like this where it's pre-programmed, but it's still been pretty annoying. Orange Pi stuff as opposed to Raspberry Pi. The Orange Pi doesn't even have built-in Wi-Fi. You have to get for a while we were using a USB dongle, but then there's like, you have both the Wi-Fi dongle and the projector, which is like too much current for the USB bus, so we probably can't use the USB dongle, so I got this one-off Wi-Fi module that they sell. And then I needed to like install this device tree overlay to get like their Wi-Fi module to work. Anyway, yeah, it was kind of a mess. I'm told that boards don't have built-in Wi-Fi often so that they don't have to like certify it like with a regulator. So they just make it a separate module. Anyway, yeah, lots of stuff like that we have to deal with, partly because we stopped using the Raspberry Pi 5. So connecting kind of works, still kind of unfinished. Running Folk on the Gadget. So Folk is a piece of software. It runs on Linux or Mac OS sometimes. It's like mostly just C. You can run it on any Linux computer in theory. In practice, there are a lot of weird quirks that you run into when you're running on a non-PC Linux computer. So we use Vulkan directly for graphics. Vulkan is like a graphics API like OpenGL. So there's just like Folk code that's built into Folk that's like Folk programs that calls into Vulkan to do all the drawing on the screen. The Raspberry Pi 5 and Orange Pi 5 both have kind of weird Vulkan implementations. The Orange Pi actually probably has a better Vulkan implementation than the Raspberry Pi, to be honest. But it is there's this random repo on GitHub that's just like, here's how you do it. And then you just like download this file from Rockchip and then install it, and then you have Vulkan. So I don't know whether to trust that, but it works pretty well. So the Vulkan API is implemented by the graphics card driver. So it can set constraints like, oh, you can only have like 10 images on the GPU at a time, and you have to like copy them in and out. Or like, oh, your shaders can't like choose between images at runtime, so you have to like add a giant if statement like so instead of just having an index into an array. Lots of stuff like that where we can kind of paper it over, but it's kind of annoying and it's like extra work for every platform. Finally, and this is probably the biggest outstanding issue, is just calibrating the gadget. So calibrating is what lets us like projection map a program. Like you see a program in camera space, like you see the April tag in camera space. And so you have some XY coordinates for where it is in the camera image, which is like a 2D image. And then you're like, okay, so I have these XY pixel coordinates. How do I turn those like into meters? Like where is it in the real world in 3D space? And then I want to project onto it, right? Like I want to outline it in green, or I want to outline it in purple, or whatever. Where do I project in the projector image, which is also XY pixel coordinates, but it's like a different XY pixel coordinates? How do I do this like three-way mapping between like camera, real world, and projector? And we actually have like a pretty good solution for this on Folk tables, which we're mostly able to apply.
Yeah, so this is a sped up version, like 20x of
I think it's like 3x, maybe 3 or 4x maybe.
all right. Me calibrating the system that's at our studio. It's called Folk Zero. It's at Hex House. And there's this, okay, the very first step, you generate a PDF. And then you print out that PDF. And you have to put it on something rigid, because it can't be floppy, because they have to be rectilinear. Okay, so you have a piece of paper on a piece of cardboard, and it's a little tiling of April tags. And then you can see that there's some missing. And so I think of it like a game. You're playing a game with the camera and the projector. And both of you are trying to figure out, how can I get enough information to the camera system so that we know we can do a bunch of linear algebra about it and eventually figure out the precise, like hopefully down to the millimeter, accurate relationship between where the camera is and where the projector is. And so the process here is like a very embodied tacit knowledge thing where like Omar and I kind of know, like tilt it at this specific angle and like move it around here, and like you have to raise it up in the middle because it's kind of a pyramid. There's a bunch of like really interesting like HCI work here that like it's just black and white right now, but like eventually I kind of want to legitimately turn it into a game, like make it red if the calibration pose is off, and like make it green and like give you points, like 0.0 out of 10, based on how many poses you've gotten correctly. So basically, once you give it 10 unique places where the camera and the projector overlap, and you have those 3D board poses, you can do a bunch of math about it and figure out that exact relationship, right? So you're actually not, it's completely the inverse of traditional projection mapping. When you see like projection mapping on like TikTok or whatever, they're usually using either MadMapper, Touch Designer, or like I've even seen people open up a PDF and like just like move little boxes around and like screen mirror, right? And so like you're basically mapping like a flat thing to another flat thing, which is like a church or something. This is the complete inverse of that. We're like trying to have an object that moves, so it's not going to be still. So we're trying to do a bunch of math to figure out exactly what this relationship is.
Right. Like once you've calibrated a folk system, like this table plane doesn't mean anything to folk. It only knows about the markers and like what's around them. So you can lift things up, they'll stay projection mapped, and that's essential to make this gadget work, since obviously there's no fixed table plane. Yeah, so a few technical problems with calibration. So thankfully, that process that we just showed, the table calibration, basically works the same on the gadget. There are a lot of like moderate-sized hurdles. So one big hurdle that I forgot to mention here is you have to project this like grid of tags onto the board, and it's hard. Like when you use the camera to view what the projector sees, you only get these like scanned subregions because it's this laser beam scanning projector. So you have to like turn the camera exposure way up to get a whole frame at once. Otherwise, you'll just get a slit of it. So you have to do that, and then okay, now that we've turned the exposure way up, it's too bright, so we need to add a brightness setting. There's like lots of stuff like that we had to fix. We had to like fix the focus. We had to like fix the exposure. But once you have successfully done a calibration, so you've like picked this up, you've pointed it at a board, you've like held it in a variety of poses, or you've like fixed this in place and moved the board around, doesn't really matter. Once you have a calibration in place, it will be valid as long as the projector and camera do not move with respect to each other. That is the key constraint that makes it work. So if they're like fixed in a lamp head, in this assembly, if they're both mounted in the ceiling, whatever, as long as they are rigid, fixedly attached to each other, the calibration will stay valid. So you can like swivel the lamp head around, you can move it up, you can move it down, you can like hold this thing in your hand and point it at different stuff. The calibration will remain valid. That is actually like pretty hard to do. Like it's pretty hard to like keep everything in here rigid. So I'll just give you an example with this. That's not rigid. It'll also swivel back and forth because it's only attached by a single bolt. So okay, so how do we like attach? So I like did all this, like, okay, maybe we put a lip inside, and we have these like other things on the sides of this that like push it inward so it can't swivel back and forth. But like lots of stuff like that. The projectors will often like want to auto keystone correct to make like a rectangular image so you can watch your movie. You also have to turn that off. We haven't even turned that off on this. I think I have to like download like an Android app and like plug it in to like turn off the auto keystone correction, auto rotation, and all this stuff. The cameras will, a lot of cameras, this one doesn't, but a lot of cameras will autofocus. You need to turn that off. You need to set fixed focus because that'll change the optics and also screw it up. The Raspberry Pi camera had a lens where like if you held it, if you held it forward, it was fine, but if you held it downward, it would like flop around, and that will also destroy your calibration. So you need to like stamp out like everything like that. Otherwise, your calibration will break. And even here, you can see the calibrations are not great. Like on a table, we can get, not on all tables, but like on my table at home, I can get like a millimeter accurate calibration. We have not been able to at least sustain that on a gadget, like moving it around, putting it in my backpack, like getting it out. So there's still a lot of work to be done on this, but hopefully we can figure it out and catch up to where we were at on our best tables.
Yeah, and so this last section is us talking about some applications of the gadget. So I would say the biggest stress test, and definitely the farthest the gadgets have gone, is back in November I gave a talk at Causal Islands in Berlin, and TSA did not take it away from me. So that was success number one.
You can see it's mounted up here.
Success number two was doing like a whole hour-long talk where, okay, so this is wild. I printed out 63 cards, and those were my talk. So I would flip through these little printed out cards. I printed them on cardstock so that they would not, crumple in my backpack. And I would flip through, the way that I presented my talk was flipping through and showing the gadget various cards. And so here they're pretty stable, right? Like they're just changing a like local server that like changes like a little like JavaScript thing to like move various load images in and out. But later in this presentation, if you watch the whole thing, which I encourage you to do on YouTube, the cards actually are, it's fully implemented folk, right? So I can move the cards and I can like project, like I can pass through the tilt and I can like wiggle around an image and like go like this, and then like the image on the projection screen in my slide software would like also tilt. It was very fun. It was mostly a demo, but like I think there's legitimate like sort of like AV applications here where you can have basically a tiny diorama, and then you can imagine moving a physical card, and then some wild visual changes or something.
And you have a lot more dynamism as you're doing the presentation, right? Like you can swap cards in and out. You can store them in different piles. Maybe you can draw on them. You can wiggle them to call emphasis. Like there's a lot of operations like that you can't do, with presentation software usually.
Yeah, it's not a metaphor.
So some of you might be aware that there was a QR show here a few months ago, and I came by, brought the Gadget, and in the hour and a half before I woke up at noon on the day and made a folk QR system before showing up the QR show at 2 p.m. So this is the promotional image for the Gadget at QR show, and then the basic idea is that you can take the Gadget and point it at a QR code, and then press the trigger button, and it will load whatever's at that URL in a browser. And we can actually probably just do that now.
I could do it live.
Yeah. I think I can do it. Maybe not. Here we go. That's the Recurse Center website. I can clear it out. Folk.computer. There we go. I can clear it out. Yeah, so I think one thing that I forgot to emphasize at the beginning is I think the way to think about the Gadget is not that it's a projector, really. It's not like projecting a screen. It's like a flashlight. Ideally, the things that it's responding to are in the world, and it just is sort of creating this extra information layer that you can see on top of what's already there. I think that's the more exciting way to think about it, rather than that it's a really small projector. That it's a sort of flashlight tool that you point at things that are actually real things.
It's also really nice to be able to scan QR codes specifically, right? After 2020, they became ubiquitous, but there's still this very dumb flow of I scan it on my phone and then I have the menu, but then I have to airdrop it or text it to other people. But what if you don't have Wi-Fi? And there's a whole crazy thing going on. Right? Whereas this is no, cool. We scanned the QR code, we got the data off of it, we loaded it a little bit, and now it just is there for everyone, and you don't have to do this passing the phone or the laptop or whatever around.
Yeah. Also worth pointing out, this was written in an hour and a half or something. The folk system already provides all the drivers, and so this is just a very simple 50-line script. I linked some C QR code scanner library, and it was all pretty easy. Yeah. So on that note, a few future ideas. I think it would be cool if when you QR scan, you get this lasso interaction where it snaps to the QR code. That actually requires a pretty sophisticated level of calibration and using both cameras and stuff. But I think that's kind of where I would want to go with that interaction. Using it as a lamp head, which is already pretty doable, where you mount it on top of a table and you can swivel it around and move it toward you, or maybe have it move it around on its own. I don't know if people played Mario Galaxy. I always think about the sound effect when you grab one of these and it's, and I would like to. I think it would be cool if you could if you have a folk table, you can pull stuff out of your laptop and drag it into the table, because this is a pointing element and not just a projector camera. So these kinds of moving things between digital, physical, virtual worlds with this drag interaction, I think would be really nice. Yeah, I was talking to some games people about you could have an escape room where you have a few of these gadgets, and then you have the walls kind of covered with things you can point at to uncover information or scare ghosts away or whatever. It's a very video game object, and I think you could do a whole room or interaction around that, and I think that would be really fun.
And we have we have links. We have links in text form, but the most important link we added a QR code for, which is our Substack. So you don't have to subscribe. I would like it if you would subscribe. But more important, since you're in New York, presumably, we are having we do open houses every month, and so
And that's all at both subscribing and going to the open houses at the link. And we'll also probably write more about the gadgets. We just put the designs up on GitHub. They're probably not really usable, but they are on GitHub. There's a lot more cleaning up that has to be done, but they're on GitHub.
It's classic open source. You can see it. Use it at your own risk. And yeah, so there's a bunch of stuff here. They're on our website. There's a bunch of supplemental images and links and stuff at folk.computer/talks/localhost July 2025.
And yeah, we'll be here. We have these two gadgets. We'll have them up for a little bit. I was just thinking, I was showing this for the first time to a friend of mine in San Francisco. And the first thing he did was he like walked up to it and smelled it. And he was like, "Does it smell like a computer?" And he was like, "Yeah, it smells like a computer." Thank you.
Thank you.
All right, if we could get the lights back on, we actually have about 10 minutes for questions. So if you have a question, just raise your hand and try to project your voice. And then if you two could also repeat the question or an abbreviated version for the recording in here, that'd be great.
Yes.
I've had this question for like a very long time. Why tickle?
There's actually a page about this on the GitHub. Well, so the question is why tickle? I think basically you want to have a scripting language. I mean, other options I think would be like Lua, JavaScript, maybe Scheme. Tickle has like a syntax that's really close to the syntax we want, and it's like really easy to extend. And the C interface is pretty good, which is actually like a lot of the implementation internally of Folk is the C interface to like talk to the hardware. So that's the basic answer. I think a few other choices would be defensible. I don't think there's that many other choices that would be defensible, but there's probably like 2 or 3 others that would be like equally reasonable. And Tickle's implementation is also really small, so we can kind of take it over. And in the next version of Folk, we've really taken over a lot of Tickle and changed it around.
2 more quick things. For people who don't know what this language is, it's not the word T-I-C-K-L-E, it's TCL, Tool Command Language, but you pronounce it tickle. And then, yeah, we wanted a scriptable environment with C embedding that is portable. And
It's actually good for embedding a lot of languages too, because it's just like the way the syntax works is like curly braces are just like a multi-line string, so you can just like have anything in curly braces and it'll just work.
Tickle's a really rare language. It turns out it's still very popular in espresso machines. And companies that have been around since the 80s or 90s, like FlightAware. FlightAware is the sort of, mysterious corporate donor. Well, the pandemic happened and they lost a lot of their money. But anyway, whatever. There are legitimate companies using it, but it's definitely a rare choice. But it works really, really well for our bespoke C plugin needs. Yes.
I know like nothing about graphics APIs.
Yeah.
Why did you choose Vulkan over OpenGL?
The question was, why did we choose Vulkan over OpenGL? So I think Omar wrote 99.9% of the Vulkan code, so I will let him speak at length about it. But I used to work in augmented reality, and so as someone who like knows a little bit about graphics stuff, and then would like open up a little shader environment, and then be like, what is this OpenGL thing? It scares me. But it scares me not because it's confusing, which it is. It scares me because there's like 800 different versions of OpenGL, and that was, I think, something we wanted to avoid. But Omar can say more.
Yeah, I mean, I think one thing that's worth pointing out is Folk is like a fairly weird Linux program. It does not use a Windows system. It doesn't use X. It doesn't use Wayland. It is its own operating system. It has multiple threads that talk to each other. And a lot of that stuff is like actually fairly annoying to do in OpenGL. And so I think we were like, we should just use Vulkan from the start. Or we had other kind of prototypes. We were using like the raw frame buffer for a while, and then it was like, okay, we should just use Vulkan. Like the support is good enough. It works well. It's kind of designed for like, okay, if you just want to blit right to the screen and you don't want to like have a Windows system, you can just use Vulkan has like an extension for that you can just turn on.
Omar breezed through this, but there's this thing called the Linux frame buffer, which you should just Google it later. It's really wild. It's a file that represents all the pixels on your screen.
Yeah, we used that for like a year.
Yeah, it turns out you can get like 25, 30 FPS out of it. Okay, we'll go back to front. Yes. It has this one. Some of them do have a speaker. The question was, have we thought about adding a speaker?
Yeah, so there's a speaker in here. You can see it. I've not been able to get it to work. It's plugged in, but it doesn't work. I don't know if it's like I need to like fix the right Linux audio stuff, or I don't understand it. But yeah, if anybody has any tips on Linux audio, let me know. No.
Okay, on the Gadget, it's never worked. We do have speakers working on Folk Zero, which is the big like studio system.
Yeah, so it might be an Orange Pi thing.
It might be a Pulse Audio thing. Anyway,
yeah. I don't know if there's like those graphs of like It looks like the like military PowerPoint. There's just like 80 different things like pointing at each other. There's like Linux audio graphs.
It turns out acquiring a speaker is easy. Programming speakers hard. Yes.
So you have the able types for like numbers that are mapped to like some program in memory. I guess I'm curious how that's stored, and also like at some point do you make a decision to do that rather than like having a QR code that could like only test the program?
Yeah, so the question was, how does the April tag mapping work, and then why did we pick April tags over, for example, QR codes? My thing here is that we spent a lot of time researching. This whole class of things is called a fiducial marker. It's a thing that you like print or somehow emblazon in the world. And then you like teach a computer system to like recognize that object, right? So
And it's like an artificially created, it's not something in nature, right? It's not something you already had. You were like, we're gonna make up this marker.
Yeah, so the most ubiquitous one are QR codes. There's also these weird color ones that are actually on the MTA subway that kind of look like color versions of QR codes.
Barcodes also are, I guess, slightly more ubiquitous. But
barcodes are the oldest one. So the thing we were looking for specifically is a fiducial marker that will not only give us data, which QR codes are phenomenal at. We also wanted accurate to the millimeter location, and it turns out QR codes are really, really bad at that. The implementations that I've seen that try to do that don't get anywhere near real time. It takes like seconds for it to happen.
Both performance. The amount of information you get, like from an April tag, you get like a 6-degree like actual like it's rotated this way, like all kinds of stuff. It's not just like location X, Y, and also like robustness too. Like if you've ever tried, like your phone doesn't really have to track a QR code every frame, right? Like once it locks in, you just click it. If you actually try tracking QR codes in real time, it doesn't really work that well.
Yeah, and then to answer your first question, the way that it works is when you press Control P in the custom folk editor, we do 3 things. We save a PostScript file, we convert that PostScript file to a PDF, and then we save a .folk file for reference later. And then we send to Cups, the like Linux printing software, we send that PDF to Cups, and then it comes out of the cute little white printer. But in that whole flow, magically, conceptually, is like a binding from, basically, we treat it as a numerical pointer. So it's like program 18 whatever is now referencing a file, that 1846.folk that's on the system. And so when it sees that April tag, it knows like in the next frame, in the next like system tick, to request whatever that is.
And usually we treat the program numbers as immutable. So like, if you print program, 1846, we're not going to reuse that. Like, the next program you print will be 1847.
And if we ever do change it, then I like take like a red marker and like scribble it out and then like write it by hand. My physical diff. Yes.
Have you ever thought about putting an accelerometer in it and doing
Oh.
localization?
Have we thought about, wait,
Do AR?
yeah, have we thought about putting an accelerometer in it and then doing a localization that way?
Also, do you think we'll ever get like a projector in our phone?
Do we think we'll...
Get like all of that and also like a screen?
Do we think that we'll ever get a projector in our phone so that we get all of that together plus screen?
Yeah, or like putting an LTE modem in the Gadget.
Yeah.
I mean, the last suggestion was LTE modem.
Right. Or if you put an LTE modem on a screen in, then you also have you just got into phone the other way. Yeah, I've thought about putting an accelerometer in. I think it's probably a good idea. The more information you have, the better. Accelerometers are small. You can get a pretty good localization just if you have a tag. If you're willing to put tags in the environment, they work pretty well. But yeah, I think it wouldn't hurt. It's just, part of me aesthetically is kind of like, you're just adding all the parts that are already in a phone. But at the same time, like actually using like an Android phone is actually pretty annoying and like has its own, like the software situation for that is horrible. Like you never see people use Android phones in robotics usually. It's still always like Raspberry Pi or something. And I think there's good reasons for that.
I have thought about what if we like stripped an Android phone and just used it as a thing that reports its accelerometer and screen state and camera, blah, 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 blah. I don't know. No, yeah, the software. It turns out Android.
It would just be like keep trying to update itself.
Right,
like
right,
the Google
right.
Play services, or yeah. I mean, seriously, like this stuff like this, like even if you use Macs, it's like really annoying.
The future of operating systems is our operating system cannibalizing Android.
I think like a projector, and if there have been phones with projectors in them, I kind of feel like part of the reason you don't see more of these portable projectors is just that the uses for them so far have not been that compelling.
Yeah,
It's like, oh yeah, you can watch a movie, like, I don't know, at a really dim. Like, I wonder if this actually kind of-
Samsung had a whole research arm dedicated to this in like the 2010s. It's been tried. It turns out heat is like a core physics problem we have no idea how to solve. Yes.
In moving the full computer from a static point to a handheld and dynamic point of use, how has the style of your software changed? Like the style of software that you write
Yeah.
on the computer?
The question was, in moving the folk computer from a static viewpoint, so the studio, to a dynamic viewpoint, the gadget, how has like the style and the capability of our software changed?
Yeah, I mean, I don't think we haven't delved that much into it yet, but I think that the QR thing is a good example. I mean, that's also the presence of the trigger button, but I think having the device, I mean, the trigger button kind of emerged from like finding that toy, but like I think having the device kind of makes you want to have a handle, which makes you want to have a trigger button, and then having the trigger button makes you want to focus, you know, kind of focus on specific things, which is very different from having this wide table where there's a lot of stuff going on. I think often you'll probably see applications with the gadget where there's like more of an active choice because you're like first person point of view, you're like choosing something. And because you just can't cover that many ambient things, you know, with the area of this if you don't want it to be really dim. So that's, yeah, I think like more active selection, more choosing. Maybe you like lock programs into it or lock modes into it as opposed to having something that's just ambiently running over a table.
Yeah,
And also like, I mean, applications where you already have a table, but you're using it as a sort of periphery augmentation, I think are also interesting and maybe an area where this will go.
Yeah, interacting with Folk Zero feels like, oh, I walked into this room that is computer. That's cool. This feels very much like you smell it and you're like, ooh, computer, I can move. And like, you know, I'm speaking about it in this like really terse way because like that's basically it, right? Like as the room computer is cool, but this begins to get you back into mouse territory where you are like driving a car where you like feel like it's a thing that's an extension of your body, and now you can like project YouTube videos as an extension of your body.
Yeah, or having
Yeah.
really high resolution, dense areas, which is hard. You know, it's really expensive to do that with a whole table projector. And yeah, historically, like precise pointing has been hard with, you know, if you're moving pieces of paper around, they're going to be kind of coarse.
Yeah. One more question? Yes.
So the handheld bulk computer is trying to recreate like one in your studio, and you have like almost all the parts. You have the cameras, you have the projector, you have the computer, but you don't have the printer.
Yeah.
Are you thinking about adding that in so you can actually create the program?
So the question is, where's the printer? Because we're trying to replicate our whole studio, and you've very cleverly noticed that there is no printer here. There's no printer today. We do have, all right, if you want to find the cheapest portable receipt printer, it's called a cat printer. It looks like a cat. That's the whole story.
It's like $14 or $5. It's somewhere between $5 and $14 on Taobao.
Yeah, if you're willing to wait a while and to import directly from China, tariffs notwithstanding, it's like $9, whatever.
And it's a little receipt printer, basically.
Yeah. And for some reason, all the people in Shenzhen have decided to standardize on this like plastic case mold of like a little kawaii cat.
Yes, yeah, or that's one of them.
This brand is called Paper Ring. This is the most popular receipt printer in China.
Yeah. Paperang is also good. Okay, so the answer is for portable printing is Bluetooth receipt printers. We have
We have used them and we have gotten them. We have done the whole, and previous talks we've done the whole, like we pull out a keyboard, we type a program, it comes out. And then you have to, the one trick is you have to tape it to a card because otherwise it'll curl. But yeah, it does work. I mean, there's still some, you know, it fades a little bit. There's like stuff to fix, but I think that flow can work.
There's mechanical issues with printing, and then there's like a bunch of horrible reverse engineering Bluetooth low energy problems.
Yeah, like Bluetooth connection will wink it. But yeah, I think,
Yeah.
you know, it fits in the box that I usually carry it in.
Yeah, it fits in like this Muji Tupperware thing with the gadget. All right, yeah, I think that's it. But we'll be here. Feel free to come up and play with our two gadgets and ask us more questions. Thank you.